Hello people, so let's have a look at the second part of this tutorial. So we are in chapter 2, and what we want to understand now is how we can export the displacements, and once the displacement will be exported, then we'll be able to start building our own Texturing XYZ or compatible with Texturing XYZ projection map. So the purpose of this chapter, let me show you kind of the different components of this chapter and what we want to do together. So what I told you before is that what we want to do is we want to remove the anatomy from the details. So what I mean by that is that basically, if I'm having a look at the different pieces I have in this ZBrush scene, so I have this model that is basically the anatomy. And what I mean by the anatomy, I mean the low frequency displacement from the model. So low frequency displacement, we want to get rid of it. I will call that the anatomy displacement, and we want to get rid of it. So when we remove that from that, then the only thing that will remain on top of the displacement map will be the details, will be the part that we took time to sculpt, will be all of this unsculpted details, all of this pattern that are really important. But again, we want to get rid of the anatomy. So we want to get rid of the low frequency displacements, and then we want to export the displacement from the microscopic displacement only. Microscopic displacement without all the details coming from the unsculpted volumes. So in the end, what will happen, that we'll end up with 3 different displacements. This one, so it's really hard to see because it has been exported with a scale at 1 from my ZBrush scene, but also it's a 32-bit displacement. But if I'm starting to play with the f-stop in Nuke, what I can see is that I have information inside of this displacement. So I have information, but the information is just a bit dim. They are really hard to see by default with the default value of my displacement. So we'll be able to change that and to replay with the range. So we have these displacements. This is basically just default displacement with all the layers that have been activated. Then we have the anatomy displacement. So low frequency displacement, you can clearly see the difference between the two. So this one is basically the low frequency plus the high frequency. It has the anatomy plus the details. This one has just the anatomy, so that's the low frequency displacement. And whenever you're exporting a displacement out of ZBrush, that's what you will get. You will get this low frequency, and sometimes you want to get rid of it. You can do that in Nuke by subtracting the low frequency from the high frequency displacement. And then the last one is the microscopic displacement. And the microscopic displacement, as you can see, has a low frequency, but it also has the high frequency displacement, the high frequency information, high frequency. The microscopic displacement, the microscopic details is this tiny grain that we want to get at the end, so we can make sure that the model is looking rougher, and we can play with that. So again, we are breaking the specularity by adding this microscopic displacement. So before seeing this different operation, what we'll be able to do, how we'll be able to customize them and combine them all together into this single map. This one with RGB value. What we need to do first, of course, is to export our displacement. So I will go in ZBrush. In ZBrush, what I will do is first separate. I can decide to duplicate the model, export them one by one like I did here, because it was easy to just export the anatomy or low frequency from this model. I can rename that low frec or anatomy. Let's rename that anatomy. The anatomy displacement doesn't need to get all the level of subdivision. Like here, I have 8 levels. 4 million polygons maximum, it's enough to get the low frequency information. This one needs to have all the details, need to have all the levels of subdivisions. But what I may need to do with this one, I don't need to export from the level 1, I can export from the level 2 or from the level not the level 4 because it already has displacement, displaced information, but I can export from the level 3, for example, and from level 3, between level 3 to level 8 or level 9, it will be enough to recover the details. Then we have the microscopic displacement. Let's go back on the highest subdivision level for this guy. Then the microscopic displacement is like this final model. I probably ended up doing another one as it looks different on my displacement. It's fine, it's just to show you how you can export these different pieces. And same for this one, you can export from level 3 to level 9 and you will get enough informations. So let's pick the first one, the actual displacement, the pattern displacement. Again, all layers are enabled. If I go into the layer, I can see that they are all enabled by default, and that's what I want. Then I will go in the plugin, multimap exporter, and with the multimap exporter, we can use the displacement. And displacement, of course, what we, oops, not layers, what we said is that we want to get as many polygons, so as many pixels as possible. So for that reason, we will export 8K. Into the displacement values, then here what you have is, you can keep them like this and make sure that you are starting from the level of subdivision from which you want to export your displacement. In this case, we'll export from level 3. And what you can do is, so you want to smooth the UVs, mid value at 0, 32-bit, XR, leave the scale at 1, intensity at 0, leave them like this, but 32-bit is important, mid value at 0 is important, so we get negative value when we dig in, positive value when we dig out, when we bulge the surface. So why the DP suffix? So the DP suffix is supposed to add one level of subdivision, one virtual level of subdivision once it's exporting the displacement out. So what it will do is it will take like the level 9, for example, virtually, it will divide it once more. So you end up 15 million polygons, you will end up multiplying that by 4, which will be about 60 million polygon, which is definitely enough. And that's what we may want to add to the export. The main reason why you don't want to use this is because it's way too heavy, it's way too intensive. So one level, one DP suffix is enough. If you add a second one, then it will take ages to export your maps. Sometimes it will not even work. So when I'm exporting displacement by default, I'm just using a value of 0. In this case, I may want one more level of subdivision just to get rid of some of the aliasing I can get when I'm really close. So one more level can help. But apart from that, I can guarantee you that if you export at 0, you will still be fine and get some great results. The name of the file is really weird, the way it's set up in ZBrush. For this reason, what I do usually is I name my current subtool with the name of the map. Then in my file name, displacement map is .zdisp.something, and the last dot at the end is made so there is a separation between the UDIM tile and the name of the map. So this one by default will be named disp.zdisp.1001 because it's UDIM1.xr. And what you can do in addition to that, you can maybe rename it, like for example, if you want it to be nose, then what you may be able to do, like here, when I will export my displacement, I will put it in the correct folder. Let's say that we want to export it in 05, just for the sake of demonstration. Then this can be my nose dot. This means that here it will be nose dot disp dot zdisp dot udim tag dot exr. So that's a long way of having correct naming conversation and convention with ZBrush. That's how ZBrush is built. There is no workaround that, unfortunately. It's really hard to export something clearly and cleanly out of ZBrush. So that's how we can do it. So remember, I will export from this one nose.something, the name of my current subtool, the name of the map, then tag.extension. I will export it from the disp, once this one exported, I will export it from the anatomy. When the anatomy is exported, I will export the microscopic. Then what I can do is to import them back in Nuke. So let's do that again. Let's say that we have exported all the maps, then we want to import them back in Nuke and we want to start compositing them together. So nosedisp should be, so there's nothing in version 4, but should be in version 5, but should be version 4. I probably messed up with the naming convention, like this one I think is the, let's have a look at what information we have in this one. This one is the Z displacement, and then the microscopic displacement. This one is the anatomy, okay. This one is supposed to be the micro. And I think that actually this one was dp sub pix at 0, and this one is dp sub pix at 1. So I will use the copy instead of using the one. So I can kill that one. Have a look at what information I have here. By looking at the red channel, not the blue channel. Okay, so that's my displacement. This one is the anatomy. And this one is the microscopic displacement. Okay, so let's have a look at how we want to combine them together. So I will put them aside and show you the different bits of this tutorial one by one, with different parts of the tutorial one by one. The nose displacement is the one from which we want to start. The anatomy is the one that we want to subtract. So for this reason, this one will be on top, this one will be on the left. The microscopic displacement will come last. So what I want to do first is to start putting that at a value of 0.5 so it's clearer for me to see what's happening. So what I can do is I can create this expression node. And in this expression node, what I'm doing is that I'm saying that all the channels are equal to the red channel plus 0.5. Because by default, if I'm looking at this one, there is value only in the red channel. That's what we said out of ZBrush. We say that we wanted to export a 32-bit displacement with only the red channel populated. So by default, there is only the red channel that is populated. So for this reason, we are using an expression node to say that we want to offset the red channel by 0.5 and that the red, green, and blue channel will be populated with the red channel plus 0.5. Then we will use a merge in minus mode. And the fact that we are putting this merge in minus is saying that what we are doing by default is that we are removing the anatomy from the displacement. Then using another expression to offset again, because if we are landing, if the mid value is 0.5, so I'm looking at that, and I can see that the mid value is 0.5, then I'm looking at that, and the mid value is also 0.5. 0.5 minus 0.5, then we'll end up having, again, the mid value at 0. So we need to offset it back. Let's compare the two. Okay, so this one and this one, slightly hard to see what's happening. So for this reason, what I did was to add a grade. And this grade, if I'm just copying this grade here, just to show you. So the difference between grade number 4 and grade number 1 is that you can see the difference here with the number 4 compared to the number 1. So number 4 compared to the number 1. In number 1, I just have the displacement that has been sculpted, not the anatomy. And in number 4, I have the anatomy in this displacement. I have low frequency displacement. I need to get rid of that. So that's why I did this minus operation. So let's do that together and let's redo these nodes to show you how it's working. So I will click on tab, create an expression, math, say that the red channel, all the channels will be equal to the red channel, and I want to offset them by 0.5. Now what's happening is that only the red channel should be populated from now. Oops, my bad. Only the red channel is populated by default because the other ones are still don't have any information. So what I could do, I could just like copy this operation in all the different slider, in all the different settings, but instead of doing that, I can just like toggle the blue and green from the first slider, and then it will populate red, green, and blue, red, green, and blue with the red channel. Okay, so I'm happy with this operation. I will just copy it over to the anatomy. Then, as I mentioned before, I will use a merge node. Plug the merge like this, and this one will not be over, but this one will be minus. So I'm removing the displacement, the low frequency displacement from my unsculpted displacement. Before and after. Okay. Now, because I've removed 0.5 minus 0.5, I just need to use this expression again. Things are really hard to see because the contrast is not enough for me to be able to use that by default with the current values. So what I want to do is to create the values, so the darker are darker and the brighter are brighter. So I will use a grade node in order to do that. And the way I'm using the grade node is whenever I'm like lifting the information and removing some dark information, or I'm making them darker, then I will have the same value, the opposite value to the gain. So let's say, for example, I'm removing 1 from the lift, then I will add 1 to the gain, and because the gain by default is equal to 1, then 1 plus 1 will be equal to 2. And slowly you will see that you will be able to really grade your values and to gain some more range inside of your map. So maybe -1 is not enough, so I can go minus 2.5, then I will add 2.5 with the gain, and I will land in this kind of range, and this can become my red channel for my displacement, projectable displacement. Okay, so we have the red channel that is ready. What we want to do then is to do a high pass. The idea of doing a high pass is to isolate just the high frequency values here and to make them available as their own channel. So similar operation to what we did with the anatomy. So we want to remove the mid frequency from the high frequency so we can isolate the high frequency. So let's do that together. Let's see how we can do a high pass in Nuke. So I will use a blur node, put that aside, and I will use a merge node. So let me just double check how it was plugged before. Okay, so we have this high frequency in B. Okay, so merge, main branch of the merge will be plugged here, then second branch of the merge will be plugged here. Then I will put this one in minus. Okay, by default we cannot see anything because we are trying to remove the same information from this node, because there is no custom value into the blur node. So what I need to do is I need to start blurring my information. And by blurring the information like this, what we are actually doing is a high pass. This is a high pass slider. And again, it's hard to see because the value, we are landing back on a 0.5, on a 0 mid value. So pick this expression node again, plug it here, and now it should become easier to see what you are actually doing. So play with the size of the blur is starting to isolate one range of information, so the high frequency range of information, and this is what we want to do. We want to isolate the high frequency range of information. Once we have that, just copy the previous grade, paste it again, and now you can also start to grade your value if you want to get more or less high frequency value. Like here, I think it's probably too much. I will put that back to -2 and put that back to 3. I'm starting to get a good range with this map. So again, I can play with the blur if I really want to isolate more high frequency values from this, or do the opposite. And once I'm satisfied with this manipulation, so the last part, of course, will be to add the microscopic details. It's a similar, it's the same workflow, microscopic details. I will just copy that because I want to do the exact same operation. Take this one, put an expression here. I want to remove, so I will put that back here. I want to remove the anatomy from the microscopic details, which is what I'm doing here. I'm removing the anatomy from the microscopic details. Then offset my values again. Use a grade. And this grade needs probably to go way lower and way higher than the previous one. Okay, red value. Oh, my bad. Minus 20 plus 20, so I should have 21 and not 30. And this is just a microscopic displacement that has been isolated now. So I have access to my microscopic displacement, my displacement, and finally my bump slider, just like I had with Texturing XYZ. If I'm looking at Texturing XYZ, this is displacement. The green channel is bump, and finally the blue channel is a microscopic displacement. So I have access to the three of them in my node graph. So what I need to do now is to start combining them together. So in order to do that, we can use a shuffle node. Okay, in this shuffle, okay, so it needs to have two branches. So the first branch of the shuffle will actually be this one. And then the second branch of the shuffle will be this one. Then I will angle it here. Double click on this shuffle. What I want from this shuffle is I will just invert it, B, RGB, okay. So from the channel B, I want the red channel, but from the channel A, I want the red channel to go in the channel green. Let's have a look at the result. So red has the information coming from the branch B. I can see that. Branch B goes in red. Then A is the channel red from the branch A is overriding the channel B from the branch, the channel green from the branch B. Okay, so I have my red and green that are combined together. Now let's add the microscopic. Same manipulation. I will just copy this shuffle, connect it here. Okay, double click on my shuffle, have a look at what's happening in the shuffle. And in the shuffle, what's happening is that I have the channel red from the A that is overriding the green. That's not what I want. I want the channel red not to override the channel green, but I want it to override the channel blue. And now if I have a look at the results, the channel blue in my combined Texturing XYZ fashion displacement is using what's happening in the channel red from the microscopic displacement. So if I have a look at the global results, I have my Texturing XYZ displacement that is combined in one package. So the last thing that I want to do in order to export that is to crop and transform. So I will transform first, The transformation will do a rotation by 180 degrees because the displacement, the UVs were reversed. So I will just transform it to make sure that I'm like making that being on the correct orientation. And then with the crop, I will double click on the crop, and the crop will just make sure that I'm not using useless pixels from the displacement. I just want to make sure that I'm using just the the area of interest from my displacement. And then double click on this crop and make sure that it's in reformat, so it's getting rid of the additional pixels. Once you're happy with your manipulation, you can just use a right node, and with the right node we just want to export it into the correct folder, so it can be this one. Copy the name, then I will name it nose disp XYZ 001.xr. You want to export it in 16 bits. You can export that as raw data information because we are using displacement, so it can be raw data. Zip 1 skyline should be enough. If you really want to export 32-bit, you can, because the displacement has been exported from 32-bit, has been created from 32-bit information coming from ZBrush, so you could do it. But most of the time, 16 will just be enough for what we are doing. And then you just want to render your displacement. And this is it for the manipulation, for the combination of the Texturing XYZ displacement, Texturing XYZ style displacement made from our own sculpts. Last tip that I can give you is basically do not hesitate to keep grading your files, keep grading the different channels until you're happy, so you can get something that's working better, maybe with the range of channel from Texturing XYZ, with the range of the map from Texturing XYZ. But apart from that, this is it for this video. So guys, see you in the next one, and the next one will show you how you can import the Texturing XYZ map in Mari, start projecting it, combine it with other pieces like this one, and play with the different channels.